Today I'm going to talk about the DF series burners on Wolf. I'm actually doing a conversion for somebody, but this is basically a video on how they're constructed and how they work. I'm actually doing this conversion, so the thing that controls the heat rating on these burners are the two orifices, one here and one inside this assembly here, and there's actually two jets that are in the control knob itself. The jets control the lowest part of the flow to through each orifice. Okay, so for example, one jet's going to control the lowest part of the low flame, which is still going to flow through the orifice. Then once you sweep wider open, there's more gas allowed to go through the orifice, but the amount of flow that can go through the jet is in that channel is restricted by the jet itself. Okay. The other part is once you sweep into the third part of the control knob, there's actually four parts to these control knobs. Anyway, the other flow starts to direct fuel flow through the second jet, okay, which is a mediary jet between the lowest part of the low circuit. It's actually the lowest part of the high circuit is what it is, okay? So it flows fuel directly through this, then it bypasses the bypass valve, that's what this is called, okay, and allows the gas to go through this orifice. So now, in the case of the fuel flowing through the bypass valve, it's still going through that orifice, but it's restricted by the total amount of flow that that bypass valve will allow. Once it overcomes that, another channel opens and then lets more gas flow through this one here. So the result is when you first open the low heat setting on the burner itself, gas is actually flowing out of these bottom holes here. Okay, this is actually for the spark igniter. This is clocked this way, but they can be clocked 180 from each other depending on where the burner is. But anyway, this is the low part. This is where the low heat comes from, and the high heat comes from this here. Okay, you'll also notice that there are these tiny little holes. Well, that's because of the fingers on the grates. They try to have the flame directed away from the fingers on the grates. So Wolf is very inventive that way. And there's these little holes here. That's where the spill, that's where excess heat comes out of. So the high flame is going to be coming out of the top part. Low flame is going to be coming out of the bottom part. Okay. The burner itself is actually broken down into two chambers. Okay, so we'll see that when we take it apart. So, for example, the high heat comes up through here. You can see. Try to see if we can see it here. There's actually an orifice down in there, which is this guy right here. Okay, this is actually a hex that comes off. It has to be removed and replaced for the conversion that I'm doing. But anyway, this is the high heat orifice. Okay, shoots gas up through here. Okay, and then the air comes in here, goes into this part of the chamber, and goes through those holes right there. Okay, the low flame. This flows into the chamber itself, okay, and then the gas is strictly coming out of these channels right here. That's the low flame, okay, and as it comes out of that channel, it goes into this part of the burner head, not this part, but this part, okay, and comes out of these bottom outlets, okay. So just the two channels are distinctly separated from each other, okay, by seals, and that's what these are all about. These are the seals that separate those two channels from each other. If you're going to repair one of these burners, or in my case, I'm actually doing a fuel conversion from natural gas to propane. You actually have to replace the two jets, and the two orifices. Okay, two orifices, two jets, and the seals. Because you do not want to take a chance of these seals inside this thing being ruptured, and they will be. If you take this apart, they will be. So you have to replace those seals because they seal the two separate parts. And you'll see what I mean here in a second. So I've got this loose because I wanted to do this demonstration, but normally they're tightened up with wrenches. But anyway, you take this guy apart here, okay, and lay this guy down there. That's the bottom part of the burner. Okay. this part comes off. This is the low heat part. Okay, it comes off, shoots through a channel in here. Okay, and bam, you have something that is actually a chamber where the gas goes through these, holes on the low heat, and then the gas comes up into here and rises up and goes through the top side holes on high heat. Okay, so it's a chamber. So in order for this chamber to work, it has to be separated so that the gas cannot cross ventilate. Okay, the way you do that, or the way it's done on these, is it uses seals. Okay, so the seals themselves, one is an O-ring. Okay, the O-ring goes into this groove, and I clean this up. If you're going to take these apart, you're going to have to clean them up and get all the old gasket material off of here and everything. So in my case, I use Scotch-Brite to clean these up. Okay, you just kind of press this O-ring into here, and sometimes you have to stretch these O-rings out because they're not quite. You just ever so slightly stretch them out. You don't want to stretch them out too much because the material's kind of stiff. It probably is going to break if you really try to stretch it. So you just want to kind of slightly stretch it before you try to attempt this, otherwise it's not going to fit. Okay, that seals the bottom. Now, this goes against the bottom of the cooking surface. So it's a stainless steel, the stainless steel's cooking surface. This part goes against the bottom. And then this part here is more, it's kind of a foam, really. But it is impervious to natural gas and propane. So it has to be spec'd to work with those. It cannot allow either one of those to leak out of here. This actually seals the top part of the burner. Okay, so it goes up in here. Now, when you put this on, you actually put it on with, when you put that guy on, you actually put it on with some Locktite. They're using 242 for this, and that actually locks the seal onto the part. Likewise, on the bottom of this, since this is a separate channel, and since if there's gas shooting up in here, it can come out, you have to seal it to prevent it from doing that. So this seal likewise gets thread locked onto here, okay, and then it all goes back together. So, and also if you'll notice, there's channels here, okay, so this here goes right through here. This one here has two channels, so depending on which side you want the igniter, that's the hole for the igniter. Depending on which side you want the igniter to come out on will depend on how you clock that. But anyway, it's sealed, okay? It goes back together. Now, I'm not going to seal it because I'm going to let the customer do that, but you put it back together. We'll just kind of go like that, okay? Remember, it'll be sealed once it's going back together. I'll just rest this up here. Okay. This gets sealed onto here, so I have to clock it to that finger. Okay, goes back together. Okay, this guy also has a clocking mechanism, so that these holes line up. Remember, some of them are smaller than others, so they have to be very specific. This guy goes back onto here. And bam, you're done. Okay, you got it back together. Then the low flame goes back on there. Oh, and I didn't show you that part of this. Okay, so when you're going to change, when I change the low flame orifice, it's actually inside of here. Okay, and again, these are loose, so I could handle them for this video. Otherwise, they'd be tightened up. This is the low flame orifice right here. Okay, so this is not the lowest part of the low flame. The lowest part of the low flame is directed through that jet. It still goes direct gas through here, but then once the knob sweeps to a certain point, then it allows more gas to go through here to its maximum flow potential. But for me to do the conversion, I have to take this guy off. This guy actually comes out of here, okay? And then I put a different one in there. Same with this. I replace this one, and I mentioned that before, but I just want to mention it again. And then, you just do this. It seals back up into this assembly, okay? Now, I've seen these assemblies. Some of them have slides on them. This one doesn't, okay? The slides are there to tune how much air travels up that tube. This is an air hole. It allows air to travel up that tube. Okay, this guy goes back on here. And bam, you're converted. So just to break down what I've just done, what I'm doing to do a fuel conversion is I'm replacing this orifice, the orifice in here, and these two jets. Now, this particular model has 4 of these burners, 6 of these burners on it. One of them is a 9200 BTU, but this one here and 5 others, or 5 of them in total, are rated at 15,000 BTU. And that's the way that works. So thanks for watching the video.